Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, this is the first of 4 that deals with partial fraction decomposition. We have a few examples to go through. The idea, we know from our arithmetic days that if we add the fractions 1/2 and 1/3, we can get the result of 5/6. Partial fraction decomposition is actually working in the other direction, working back from a single rational expression and try to express it as a sum of 2 or more rational expressions. So for example, if we have 5/6, and I know the factors of 6 are 2 and 3, I'm trying to find 2 numbers, A and B, such that if I place them over 2 and 3, their sum is equal to 5/6. And so from above, we know that A and B would be 1. We're going to do the same thing, but with algebraic expressions here. So let me get rid of the arithmetic. And let's try this with this rational expression, 3x plus 14 over a denominator that's already factored, x minus 6 times x plus 2. I want to be able to rewrite this as a over x minus 6 plus b over x plus 2. And the first step is to clear the equation of fractions. So I'm going to multiply both sides by the common denominator, or the denominator that's on the left-hand side, x minus 6 times x plus 2. Now on the left side, everything divides out in that denominator, and we're left with just 3x plus 14. On the right-hand side, when we distribute that denominator into the first fraction, the x minus 6's divide out, leaving just a times x plus 2. And same idea with the second fraction, we're left with b times x minus 6 after the x plus 2's divide out. Now this equation doesn't have any domain restrictions, so this is going to be true for all values of x. And if we pick a convenient value of x, like x equals 6, we can use that to solve for one of these unknowns, a and b. And once we have one, we can easily get the other. Why did I say x equals 6? Well, if I plug in 6 for x, that last term on the right-hand side is going to be b times 0, and that unknown will disappear, leaving an equation that just has a in it. So I'm going to do that. Let's plug in 6 for x. And I'm going to do this in a different color. 3 times 6 plus 14 equals a times 6 plus 2 plus b times 6 minus 6. By the way, I picked 6 because I know 6 minus 6 was 0. I could also have put in -2 for x because -2 plus 2 was 0. On the left side, 3 times 6 plus 14, that's 18 plus 14, or 32. On the right-hand side, a times 6 plus 2, that is 8a. And b times 0, this piece goes to 0. So we can solve this for a by dividing both sides by 8, and we find out that a is 4. So we're halfway home. Now to get the value of b, I can use the same approach that I just did, but now I'll put in -2 for x. So if I use x equals -2, that's 3 times -2 plus 14 equals, I'm sorry, that's not a any longer, that's now 4 times -2 plus 2 plus b times -2 minus 6. On the left-hand side, 3 times -2 is -6, plus 14, that's positive 8. On the right-hand side, 4 times 0 is 0, and we're left with -8b. And if I divide both sides by -8, I find out that b equals -1. So I've got my values for a and b that I needed up at the top. But before I do that, I'm just going to show you that I really could have used any value, not just -2, but really any value for x to figure out what the value of b is. So let me change colors again. let's say we use 0 because 0 is easy to evaluate. 3 times 0 plus 14 equals 4 times 0 plus 2 plus b times 0 minus 6. The left side becomes 14. The right side is 4 times 2, or 8, minus 6b. Subtract over the 8, we get 6 equals negative 6b. And again, divide by negative 6 this time, and we get b equals negative 1. So we would have got negative 1 either way. Use a convenient value to get the first one, then you can use whatever you want to get the second one. I now know that the value of a that makes this true is 4. The value of b is negative 1. So 3x plus 14 over, let's see, we had x minus 6, x plus 2 equals 4 over x minus 6 minus 1 over x plus 2. Or you can think of it as plus negative 1 over x plus 2. By the way, you can check this by subtracting the two expressions on the right-hand side. You'll see that you end up back at what we had on the left-hand side. Maybe I'll show you that. If this was my problem, if all I had to do was subtract these two rational expressions, the first fraction would turn into 4 times x plus 2 over x minus 6, x plus 2. The second minus 1 times x minus 6 over that x minus 6, x plus 2 denominator. Distribute in the numerator, we get 4x plus 8 minus x plus 6 over that common denominator. And when we combine, minus x plus 6, when we combine like terms on the top, we get 3x plus 14 over x minus 6, x plus 2. So this checks out. You don't have to do that check, but just to show you that, yeah, this actually worked out to be correct. All right. Let's try another one. This time, the denominator is not factored. So we've got x squared minus 12x plus 27. And we really want to factor that denominator if we can. And this turns into x minus 3 times x minus 9. So the answer is going to be a over x minus 3 plus b over x minus 9. That's the partial fraction decomposition. I just need to figure out what a and b are. Multiply through by the common denominator, and what you're going to be left with is this equation. 12x minus 66 equals a times x minus 9 plus b times x minus 3. What value should we use for x? We want to use a value that makes either a or b disappear from this equation. Last time we got rid of b. Let's get rid of a this time. I'm going to use the value x equals 9. 12 times 9 minus 66 equals a times 9 minus 9 plus b times 9 minus 3. On the right-hand side, 12 times 9 is 108. Minus 66 is 42. A times 9 minus 9, that's 0. And 9 minus 3 is 6, so we have 42 equals 6b, or b equals 7. Now again, we can use whatever value we want. I'm going to use x equals 3 here. (12 times 3 minus 66 equals a times 3 minus 9 plus our new value of b, which was 7, times 3 minus 3, putting in 3 for x in the original equation. And this piece turns into 0. On the left-hand side, we've got 36 minus 66. That's negative 30. On the right-hand side, we've got negative 6a. Divide by negative 6 on both sides, and we find that a equals 5. So our partial fraction decomposition, I would put in 5 for A, 7 for B. 5 over x minus 3 plus 7 over x minus 9. That is the partial fraction decomposition of 12x minus 66 over x squared minus 12x plus 27. One last example in this video, and that example, what we've seen so far is that the numerator has had a smaller degree than the denominator. But if the degree of the numerator is equal to or greater than the degree in the denominator, we need to divide first to pull out the quotient, and then we'll use partial fraction decomposition on the remainder. Now here in problem 3, we have a numerator of degree 3, but a denominator of degree 2. So we need to begin by doing long division to figure out what the quotient is, and then use partial fraction decomposition on the remainder part. So little long division. We're going to divide x squared plus 3x minus 28 into x cubed plus 5x squared minus 9x minus 75. We work with the two terms of greatest degree. That's x squared in the divisor, x cubed inside the division box, and we multiply x squared by x to get x cubed. So x times x squared is x cubed, x times 3x is plus 3x squared, x times negative 28 is negative 28x. Now we subtract. X cubed minus x cubed is 0. 5x squared minus 3x squared, that's 2x squared. Negative 9x minus negative 28x, that's like negative 9x plus 28x. That's plus 19x minus 75. Now we'll do it again. What do we multiply by x squared to get 2x squared plus 2? Multiply 2x squared plus 6x minus 56. Subtract 2x squared minus 2x squared is 0. 19x minus 6x, that's 13x. Negative 75 minus negative 56, or negative 75 plus 56, that's minus 19. So this rational expression is actually equal to x plus 2 plus the remainder 13x minus 19 over the original divisor, which, by the way, it does factor, but we'll do that on the next line. X squared plus 3x minus 28. So we need to work partial fraction decomposition for that remainder. 13x minus 19 over x plus 7 times x minus 4. That will be equal to a over x plus 7 plus b over x minus 4. Again, we've only had single non-repeated linear factors here. So no x plus 7 to the third power. No x squared plus 4x plus 7 as a factor in the denominator. So when that's the case, for each factor in the denominator, we put a new constant over that factor and take their sums. So a over the first factor plus b over the second factor. Multiply through by the common denominator. The left side becomes 13x minus 19. The x plus 7 divides out, leaving a times x minus 4. For the second term, the x minus 4's divide out, leaving b times x plus 7. And now we can get rid of one of these constants. Let's use x equals 4. Because 4 minus 4 is 0, and that's going to make this term disappear, leaving only b to solve for. 13 times 4 minus 19 equals a times 4 minus 4 plus b times 4 plus 7. On the left side, we've got 52 minus 19, that's 33. On the right side, that term goes to 0. We're left with 11b. And when we divide through by 11, we find that b is equal to 3. So we've got half of our partial fraction decomposition. To get the other one, we can substitute any value that we would like back into this equation where b now is equal to 3. So obviously we could put in -7 if we wanted to. Probably not a bad idea. 13 times -7 minus 19 equals a times -7 minus 4 plus b, which is now 3 times -7 plus 7. That term's going to 0 anyway. On the left side, we have my favorite product, 13 times 7, that's 91. So -91 minus 19 is -110. On the right-hand side, it's a times -11. And when we divide through by -11, we get that a is equal to 10. So we have found our values for a and b in the partial fraction decomposition. And if you recall, we started with x plus 2, and then we've got 10 over x plus 7 plus 3 over x minus 4, putting in 10 for a and 3 for b in that breakdown. And again, we started with a quotient of x plus 2, so that belongs in front of all that. All right, that's it for this video. In the next video, we'll take a look at what happens when we have factors that are repeated in the denominator.